Welcome back to Pure Science Education. Today you will be looking at electrolysis, which is quite a popular topic at GCSE. So what does the word electrolysis mean? It's made out of two words, electro and lysis. Electrolysis is a Greek word where electro means using electricity and the word lysis means splitting. So electrolysis is a technique used to split metals from its ore using electricity. Where do we use electrolysis? So electrolysis is used if the metal is more reactive than carbon. If you look at your reactivity series, if a metal is less reactive than carbon, you can use carbon to extract the metal from its ore. If the metal is more reactive than carbon, then you can use electrolysis. So in order for you to use electrolysis, we need to have certain conditions. So for electrolysis to work, number one, you need to have a molten or liquid ionic compound. Now, number two, you're going to use electricity to split the metal from its ore. So let's look at point number one, molten liquid ionic compound. The word molten means melted. So why ionic liquid compound and why not a solid? So if you have a molten or a liquid compound, what happens is all the bonds have been broken. So if all bonds, the electrostatic bonds, have been broken, and like I said, molten means melting while it was melted. So when the bonds break, it creates the free-flowing electrons or ions, which allows to carry electricity. So if you have a solid ionic compound in comparison to molten, it doesn't conduct electricity because it doesn't have any free-flowing electrons, and all the bonds are being connected by strong electrostatic forces. So let's look at how this works now. So here is this structure, a diagram given to you. So I'm going to look at lead bromide. So lead bromide is PbBr2. I have one lead and two bromine ions, and what we're going to do is look at them. So in order for you to do electrolysis, you need to have a molten or liquid solution of lead bromide. That solution is called the electrolyte. So electrolyte is your liquid or your molten liquid that contains, so electrolyte contains metal ions, the next thing you're going to have is electrodes. So you will have a positive and negative electrode. So anode is positively charged, cathode is negatively charged, and the role of the cathode and anode is where your metal will be collected. So the thing here is your power pack, which is providing you the energy, the electricity for electrons to be separated. So as you can see, the PB's got positively charged because it's a metal, and bromine has got negative charge as a non-metal. So when the electricity will flow through the power pack, all the positively charged will go, positively charged ions will go on the cathode here, and on the negative side will go this on the anode, which is this side here. So when this is happening, what actually is happening in the beaker? So if we move this diagram slightly, so if you look within the beaker, we have got PbBr2, which is a lead bromide, and if I was to look at the individual electrodes, the Pb is what we want to create, and you start off with Pb two plus, you get 2E minus, and if you look at the bromine, you've got plus 2E, and to balance that, we're going to get Br2, and to cancel these out, we're going to have 2 of them. And these are your half equations for each electrode. So if I start with my Pb plus, it's got 2 plus charge. To make my Pb, to cancel the 2 plus, I'm going to need 2 minus here. So this here gets cancelled with these 2 electrons. If you cancel these 2 out, then what you're left with is your, if I cancel that and that, I'm left with my Pb. And again here, to cancel out the 2Br and 2Br, you got 2E minus charge here. So this was a quick summary of Introduction to Electrolysis. I hope it helps. Thank you.